Indices. The singular of indices is index. Index form is a way of writing very large numbers or very small numbers. If I have 1 million, this will just be 10 to the 6th. So we find out that economize space to write this number, which is very large. So this number is said to be in index form. So if I'm given a number like 6 to the 3rd, 6 is called the base, and 3 is called the index, or power, or exponent. The expression x to the n is read as x raised to the power n. So I can say 4 raised to the power 5. I can have half raised to the power 3. I can have 2.5 raised to the power 2. What does 4 raised to the 5 mean? This means 4 times 4 times 4 times 4 times 4. This is 4 multiplied by itself 5 times. Half raised to the power 3. This will be half times half times half. 2.5 raised to the power 2. This will be 2.5 times 2.5. So, one take-home message here is that indices help us to write down numbers that are very large or very small, so as to economize space and time. The laws of indices. Let's consider this. 6 raised to the power 3 times 6 raised to the power 2. What this actually means is 6 times 6 times 6 times 6 times 6. What does this give us? This gives us 6 times 6 times 6 times 6 times 6, which is equals to 6 to the 5th power. 1, 2, 3, 4, 5. So there are 5 6's here. So write 6 raised to the power 5. So what do we see? How can we get this 5 from these powers? We see here that this is equal to 6 raised to the power 3 plus 2. Let's try another one. 7 raised to the power 2 times 7 raised to the power 4. This will give us 7 times 7 times 7 times 7 times 7 times 7. This will be 7 times 7 times 7 times 7 times 7 times 7. This will be equals to 7 to the 6th. How do we get 6 from these two indices? This is 7 raised to the power 2 plus 4. Hence, in general, a raised to the power m times a raised to the power n will give us a raised to the power m plus n, where m and n are integers. Evaluate 4 raised to the power 3 times 4 raised to the power 7. This will give us, will be equals to 4 raised to the power 3 plus 7. This is equals to 4 raised to the power 10. Let's take the other problem. R raised to the power 5 times R raised to the power 8 will be equals to R raised to the power 5 plus 8. This will be R raised to the power 13. This is the first law of indices. So the first law concerns multiplication. Let's now look at division. 2 to the fifth divided by 2 to the third. What this actually means is 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2. So these two cancel. Here we are left with 2 times 2, which is equal to 2 raised to the power 2. How do we get 2 from these powers, 5 and 3? I see that if I subtract 3 from 5, I'll get 2. Another way of writing this is 2 raised to the power 5 divided by 2 raised to the power 3. This number down here is called the denominator, and this is the numerator. So let's take our law concerning division. If I have a raised to the power m divided by a raised to the power n, this will be equals to a raised to the power m minus n. Example, 8 to the fifth. Example, 8 raised to the power 5 divided by 8 raised to the power 4. This will be equals to 8 raised to the power 5 minus 4, which is equals to 8. 8 raised to the power 1, which is just 8. Let's look at the third law, which concerns exponents. Let's do a demonstration here before we state the general rule. If I have 3 raised to the power 3, all raised to the power 2, this is actually 3 times 3 times 3 times 3 times 3 times 3. All of this will give us 3 raised to the power 6. And how do I get 6 from 2 and 3? I see that multiplication will do the trick. If I say 3 times 2, I'll have 6. In general, a raised to the power m all raised to the power n is equals to a raised to the power m times n. Evaluate 8 raised to the power 7 all raised to the power 3. This will be 8 raised to the power 7 times 3. This is 8 raised to the power 21. All this gives me 5 raised to the power minus 4 all raised to the power 9. So here I'll have 5 raised to the power minus 4 times 9. This will be 5 raised to the power minus 36. All I have here, minus 2 raised to the power 3 all raised to the power 4. This will be minus 2 raised to the power 3 times 4, which is equals to minus 2 raised to the power 12. Let's now look at the fourth law, which concerns the zero index. Let's do a demonstration. If I have 2 all over 2, answer there is 1. 2 raised to the power 3 all over 2 raised to the power 3, answer there is 1. If I apply the second law, 2 raised to the power 3 divided by 2 raised to the power 3 will be equals to 2 raised to the power 3 minus 3, which is equals to 2 raised to the power 0. 2 raised to the power 0. I can see from here that 2 raised to the power 3 divided by 2 raised to the power 3 is equals to 1, which is equals to 2 raised to the power 0. This means that 2 raised to the power 0 is equals to 1. So what is our general rule here? A raised to the power 0 is equals to 1 for all values of a excluding 0, which therefore means that a cannot be equal to 0. So if we're given 8 to the 0 will be equals to 1, 101 raised to the power 0 is equals to 1, minus 23 raised to the power 0 is equals to 1. Let's look at the fifth law that concerns negative index. Let's consider this. a raised to the power 2 divided by a raised to the power 4. This will give us a raised to the power 2 minus 4. This is a raised to the power minus 2. Applying our second law. Let's attempt this problem by expanding. A raised to the power 2 divided by a raised to the power 4. This is actually a raised to the power 2 divided by a raised to the power 4, which is a times a divided by a times a times a times a. So this cancel. We are left with 1 all over a times a, which is equal to 1 all over a raised to the power 2. So let's call this equation 2, and this is equation 1. We find here that the answers will have the same initial problem, which therefore means that the answers should be the same. So here I'll say a raised to the power minus 2 is equal to 1 all over a raised to the power 2. In general, a raised to the power minus n is equal to 1 all over a raised to the power n. Evaluate 3 raised to the power minus 4. This is equals to 1 all over 3 raised to the power 4. Evaluate minus 2 raised to the power minus 3. This will be equals to 1 all over minus 2 raised to the power 3. Let's look at the sixth law, which concerns rational indices. Let's consider a raised to the power half. If we decide to square all of this, we'll have a raised to the power half all squared. So by our third law, which says that if we have exponents raised to another exponent, that is a raised to the power m or raised to the power n, will give us a raised to the power m times n. So here we'll have a raised to the power 2 all over 2, which is equal to a raised to the power 1, which is just a, by third law, by law 3. What am I saying here? I'm saying here that a raised to the power half all square is equal to a. I take square root of both sides. I'll have a raised to the power half is equals to square root of a. Let's try another one. If I have b raised to the power 1/3 and I cube it, this will give me b raised to the power 3 all over 3, which is equal to b. So b raised to the power 1/3 all cubed is equals to b. I take cube root of both sides. So b raised to the power 1/3 is equals to cube root of b. In general, a raised to the power 1 over n is equals to the nth root of a, where the base is greater than 0 and n is not equal to 0. Evaluate 27 raised to the power 1/3. This will be equal to cube root of 27, which is equal to 3. Evaluate 100 raised to the power half. This is equals to square root of 100, which is equals to 10. Again, by law 3, a raised to the power 2 all over 3 is equals to a raised to the power 1/3 all squared, or a raised to the power 2 all raised to the power 1/3. This will give us the cube root of a raised to the power 2. Hence, for any rational number m all over n, where n is not equal to 0, we have a raised to the power m all over n. We shall have the nth root of a raised to the power n. So let's simplify. 100 raised to the power 3 all over 2. This will be equals to cube root of 100 squared, which is the same as cube root of 100 all squared. This is cube root of 100 is 10 all squared, which is 10 times 10, 100. So we can state this our law relating to rational index as a raised to the power m all over n is equals to the nth root of a all raised to the power n. So this form and this form are the same. Let's do 32 raised to the power minus 3 all over 5. Let's first of all remove this negative index. This will give us 1 all over 32 raised to the power 3 all over 5. This will be equals to 1 all over the 5th root of 32 cubed. This is equal to 1 all over, what is the 5th root of 32? Which is 2. This is 2 cubed. I've simplified this applying the laws of indices.